and I just started the recording. Is there anyone new to the project in this call, or someone who has never attended this meeting in the past and want to introduce themselves? Then please feel free to speak up. I'm going to mute my microphone for a while. Okay, if not, we can move on. The first item from Shukun introduced the automatic network configuration design proposal. Shukun, please, go ahead.
Yes, could you hear me?
Yes.
Okay. So this is a proposal which has been discussed in a parallel community meeting on Friday afternoon in Japan. And we have discussed. So today I want to share the status of the latest status of this proposal. I want to introduce to the community, the whole community, so we can get a review from the whole community. So to present the review, can I show my screen?
Sure. I'll stop sharing. Can you please try?
Okay. Can you see the
Yes, we
proposal?
see it.
Okay. Okay, so the name is automatic network configuration, and the proposal is to expand the scope of Metal3 to include an API to manage physical network devices. So, and the motivation is because we are do some automatic provisioning for the bare metal servers, and the server will connect to some physical networks, the devices, and for now, we before provisioning, we need to prepare those network environment, and we want to do it also do it automatically. So here we have this proposal. And the goal is define a Kubernetes API for configuring network device and automatically configure the network infrastructure for a host when adding to a cluster, and do network configuration when deprovisioning the hosts, and then design network abstraction that can represent any of the target networking configuration. And what these non-goals are implement a network controller which is aimed at being an integration with an existing controller only, and also implement a solution for a specific underlying infrastructure. So, and in the future, we may want to so we are here we are trying to define the Kubernetes API for configuring network devices. And at first, we want to implement the switch related API. So in the future, we want to implement a solution for the link aggregation about switch, and also the ARDP feature in the switch. And so here is the proposal itself and some user story. Like as a consumer of Metal3, when adding a machine resource to the cluster, according to the network configuration of the cluster, the physical host will be automatically connected to the corresponding logic layer 2 network segment. And also, as when a machine is deleted from the cluster, the corresponding network configuration will be automatically deleted. And also, if as a user or admin, smart NIC in VMH needs to be provisioned or pre-configured and then capable of an operation management. And the next is not something like link aggregation or ACL rule, something like that. And the next is design details. And to define design the Kubernetes API, we have abstracted the following roles. So first is the device. So device is representing a network device like switch or smart NIC or router. And this is an example for switch. It will have power on, power off, and get port attribute, set port attribute, or reset port. And then there will be a provider device. The provider device will represent the different ways to connect to the actual device, and the provider will know how to interact with that device. And each device will have a specific device port. The device port is a specific port on that device. And then there will be a configuration. It is the network configuration that will be deployed on some device port. And then the device controller and the device port controller, which are responsible for those device port and the reconciliation of those CRD. And here is the image, and shows that the switch or smart NIC as the example of all the roles, and how it could be deployed with the Metal3. So we have this determined the contract for our network tool, and for example, if we are using switch, then we will have a switch as the device, and switch port, which the switch will represent a specific physical port on the switch, and the switch port can have switch port configuration, and the switch will have a provider switch which knows how to interact with the actual switch, and the provider switch will can have different implementation, like if we are using Ansible as the backend, and we are interact with the Cisco switch, then there will maybe Ansible Ansible backend using like Cisco collection, something like that. And here the next is workflow. So this image shows the network related parts, the workflow itself, not integrated with Metal3. And there will be admin and user, and switch port controller, and this is so from the workflow, all of the design is specific to the switch. And here the switch port controller and the switch controller and Kubernetes and the physical switch. So the admin is those who actually own the physical environment, so they can create the switch custom resource, and then the user is those who actually consume the environment. So the user can only create the switch port configuration, that is the network configuration which they want their environment is, and they can update the switch ports custom resource they can fill the they can like I need the switch port to take this switch port configuration which I created, and then the switch port controller will started to configure the port. And also for updating, the user can remove the switch port custom resource, the configuration field, and then the port will be deconfigured. And the user also can update the configuration field, and so the port will be deconfigured and then configured to the new switch port configuration. And for delete, so the switch and the switch port CR can only be deleted by the admin. So if the admin remove the switch CR, then the related switch port CR will be also deleted, and each port will be before deleted the switch port, each port will be deconfigured by the controller. And so if integrated with Metal3, the workflow is, so here will be a long part, and so first integrated with Metal3, the first the administrator will need to create a related CR like switch, provide a switch port, and BMH, and then the user can create a Metal3 machine template which referencing switch port config. So that means whenever the user creates the machine, they want the machine to have some specific network configuration. And then the machine is created, and Capim3 will then check that there will catch that and there is a new machine, and then it will choose the satisfy the BMH by some new function that will add to Capim3, and it will according to the network configuration and the BMH actual unique condition, it will choose the BMH which had the ability to satisfy the user network requirement. And then the Capim3 will set the some new field in the BMH which we will add to the BMH. It will told the BMH that you should have this configuration in some specific NIC, and then the BMO will check this these configurations and then set the related switch port to tell that the switch port need to be set to that configuration. And finally, the switch port controller will started to configure the port, and BMO will detect that each port is ready, is active, and then it will continue to provisioning. And for the provisioning, so so the Metal3 machine is about to be deleted, and then the Capim3 will call some new function like a deconfigure network, and it will catch every related switch port and remove the configuration ref. So the the BMO will start to remove every configuration from the switch port, and then the switch port controller will start to deconfigure the actual port. And after that, the BMO detects that every port is in idle or some other. So it will and the in idle and only in the specific port for Pixie boot is inactive, then the BMO will start to deprovisioning the BMH. And for deletion, well, this is simple. All the resources just to be deleted, and so the switch deletion is blocked until all switch ports are deleted. And if each port is being deconfigured, then the switch ports will be deleted, and finally the switch will be deleted. So the next is changes to the current API. So for Metal3 machine, we will add a new field called network configuration. And in this field, this is a list. We will the user can list every network configuration here they want the machine have. So like this field will have configuration ref, which is a reference referred to network configuration, and the NIC hint, which is used to specify which port or which NIC in the BMH should have this configuration. And for BMH, we will have add a new field called ports, and in this ports field, every BMH NIC related information will be listed here, be added here, like MAC and its name, and the port here is which is a reference to device port, and the device port is connected to the BMH to this NIC. So like if the port, if ETH0 is connected to a switch port 0, then it will have the reference here. And the PIX configuration here is means that during before provisioning this switch port, this NIC should have the PIX configuration. It should be used for PIX put, and the configuration should be used by this configuration. And if PIX configuration is nil, then that means this NIC won't be used in PIX boot. And finally, the configuration here is used for when after provisioning, when the worker is running, the NIC should have this configuration for some other work. And we will add new CRD and the controllers. First, the switch CRD itself, and the provider switch. So the provider switch will have login information of the switch for different protocols. And here are some examples for, like, if we are talking to the switch by command line, then we will have CLI switch CRD. And if we are using SMP, then we will use the SMP switch, and also netconf and OVS, something like that. And the switch CRD itself here, and you will have a provider switch and ports. And the ports here means the is a map, and the key is a name of the switch port, and the value is the actual value here is some specification information about the switch port CR, and like name is the actual port name in the switch port, like if there is a switch port CR, and which has a name is switch port example, and then this switch port CR is actually port 0 in the switch, then here will be port 0. And understand the name disabled and the VLAN range and the trunk disable here there are some restriction which the admin can add to this port, so they can prevent the user to access to another tenant network, something like that. And here is the Switchport CRD. And it will have owner, which is a switch, and it only have in its spec it only have configuration name. Means that the switch port should use this switch name switch port configuration. So the user can only modify this field. They can only change the configuration the switch port should have. The user can't change the switch port, can't change which port the switch port represent, and also can't change the switch itself, that the switch port that okay, cannot change the which switch that should own the switch port. And here is the switch port configuration, which can be created by a user. A user can create something ACL rules and which untitled VLAN the port should be put in, or some other things here. And then come to switch port controller and the state machine. Well, I think I'm gonna skip this part, and we also have discussed some the permissions and multi-tenancy models about this network related tools. And some remained details and test plan, the upgrade downgrade strategy, and we have, and according to this design, we have also did a poke to and demos to show how this network operator works with Metal3. So I will start to show the demo. Okay, can you see the demo? See the?
Yes.
Okay, so here in the demo, we are using everything. We are integrated with Metal3 dev. So, and everything in virtual. The switch we are using OBS, and here you can see the switch. The bridge is BR test, and the inside of the bridge there are node 1 port and node 0 port, which we will use today for for demo. And you can see the node 1 is in tag 11. And so currently we already have created a node 1 BMH provisioned, and we have created a switch example. Yes, here. The switch have 2 switch port. One is switch port node 0, and in that switch, the switch port node 0's real name is node 0. So here, and the switch port node 1 is node 1. So we have 2 switch ports, and switch node 1, and because switchport node 1 is already being used by the node 1 BMH, so the state is active and it's being moved into the tag 11. And the switch node 0 are not being used, so the state is idle. And also for in the switch, we can see we have a provider switch. The kind is obvious switch. Yes, in the obvious switch spec, we can see that the bridge is BR test and the host and also the secret to access to into the switch, into the obvious switch. And then so we can also, then if we want to start to use this network tool, so we will create a new BMH. So I will create the node 0, and in the node 0 spec in ports, it will have one port specific here, and the switch port is connected to is switch port node 0, which means in the obvious switch, the node 0 is connected to this NIC, and it should this NIC should have PXE switch port configuration. So before provisioning, the node 0 should have this PXE switch port configuration, and after provisioning, the node 0 will have switch port configuration node 0. So if we see PIC, so we have already created those two switch port configuration. And it's a very simple configuration. For PXE configuration, we will have only untagged VLAN 10. And for switch port configuration, node 0 will have the untagged VLAN 11. So after, and also node 0 already have the same configuration. So the node 1 is 11. And if we create the BMH, sorry. Then you can see the node 0 has been automatically put into the tag 10. And the node 0 started to inspecting. And after that, it will be getting to ready. And I won't start to provisioning the node 0 because it will take a lot of time. And the node 1 is the example that after provisioning, the node the port of node 1 will be automatically put into 11. And if we deprovision the node 1, then the node, you will see the node 1 here will be moved into 10. Okay, the node 1 is moved into 10. And the BMH is now get into deprovisioning. And that's all. That's the demo. And that's it. We have the proposal here, and we want to get it reviewed from the community. And we also want to discuss about how to create a whole framework for testing, and there are also some other issue remained to be discussed, and at the current point, we will have discussed it on the Friday parallel community meeting. That's all from me. Thank you.
Thank you, Shukun, for detailed walkthrough and for the great demo. Are there any questions to Shukun regarding the network configuration, like proposal or any demo or feedback?
Hey, this is Sandhya. I agree that the proposal and the demo are really in great shape. Like the proposal is very detailed. Going back to the diagram, I just have one question regarding when you encounter failures when adding configuration to the actual switch. I haven't read the proposal yet. I don't know if you're talking about it in the proposal already, but what happens when you try to push configuration and something fails on the switch?
Yes, so I skipped the state machine of the Switchport controller, and it will have idle from idle, and start configuring, and we'll come into configuring, and if some error happen here, then it will be being queued again, and then output the error message to the user so they can know what happened in the switch. And also we have added, so we didn't write here, but we have some verify in action in the code. It will check the configuration, check if the configuration is correct or not, and if it's not correct, then it will also return the error to the user to inform they are not correct configured the switch.
Okay, thanks.
So is this only for V switches? I just don't see how this is going to work with bare metal switches. There's so many different permutations of OSs and OS versions. I'm just curious what your thoughts are.
Sorry, could you say it again?
Well, you did this with a V switch, an OVS switch, which is fine. That's easy and relatively straightforward. But when you start working with vendors like Cisco, Juniper, and other bare metal switches, and the different OS versions they have, and some of the subtleties of the API changes, I'm kind of interested, is this only for Open vSwitch or vSwitch in general and not bare metal?
So that Ansible networking project is kind of an abstraction layer for a bunch of different switches. So I think I missed the start of this talk, but
yeah,
the plan
different switches have different OSs, like Cisco and Juniper. There's some subtle differences in how you configure the switch and get in to do the VLAN tagging and all that stuff. And it's not a straightforward switch config. So I'm kind of confused. Is this only for the vSwitch type, or is this also for bare metal switches?
If I may jump in there, like we have talked about, so a provider switch CR that will be actually representing the switch that is used as a backend. So you can implement your own controller for a specific dedicated type of switch, or if so, it's basically the goal is to leave it open so that if you want to add support for something, you just create a new CRD with a dedicated controller and add that and get running.
Will any switches actually supported out of box?
Sorry, didn't get that.
Yeah, the question is if any bare metal switches will be supported by this project out of box, rather than operators writing their own implementations.
Well, Shokun, you can comment on this, but considering the proposal is coming from Fujitsu, I expect that their own switches will definitely be supported. Then I guess it will be up to the community to add the mainstream ones, let's say.
Okay, actually I see a problem with that because I don't think we should add a single vendor implementation in Metal3 upstream. On the other hand, I pasted a link in the chat. There is this network runner, which is what is backing network in Ansible, which is an Ansible-based abstraction around different networking switches. So if we implement a backend based on that, this proposal will make much more sense. While I have your attention, I'm also concerned about the maintenance of this proposal because it seems to me that the amount of code that will be brought under Metal3 is the same as Metal3 current, or maybe even larger because Metal3 doesn't include Ironic. So I guess I have two questions. How will you ensure that we have some generic bare metal implementation? Because for me, it's a requirement. And what are we going to do with maintenance burden? How is it going to work with our very limited resources now?
Well, those are very good questions. I think they will be the next topic discussions for for our next meeting. The proposal is work in progress, as you have guessed, right? So we're gonna probably think on this and come back with an answer later.
So I had a similar question, which again we can maybe take to a future meeting, but thinking about some of the upstream cluster API discussions around like the load balancer provider and you know, whether or not it makes sense to have this switch automation be tightly coupled to Metal3, or whether it, you know, could be potentially useful in other cases. I can imagine some VM-based environments might want to interact with the switches for similar reasons. And although I don't see an obvious place in the current cluster API model to plug this in, like, you know, is it worth having that discussion with the broader community and seeing whether there's any other comparable efforts that could be leveraged instead. As Dimitri said, it seems like a pretty broad expansion in the scope of Metal3, and although it's probably quite a common request in bare metal environments, it doesn't seem like switch configuration is necessarily only applicable to bare metal. So it would be good to maybe see if there's a more generic approach which we could consider as an alternative before committing to this direction.
So I just want to say thanks for putting together this like very thorough looking proposal. I have not had a chance to review it yet, but I will attempt to make some room in my schedule to do that. I do kind of agree with Dimitri that we need to have a generic implementation somewhere, and this applies not just to the switch stuff, but in general, I would say that I don't want the Metal3 community to become the place where hardware vendors come to collaborate. Or rather, I don't think we have the capacity to become that. So for the actual bare metal host stuff, you know, ironic is that for us, we have the hardware vendors collaborate in the ironic community. They contribute third-party CI to that to test that, you know, their hardware works with ironic, and then we try to use ironic's abstraction so that we're not required to duplicate all that infrastructure. We don't have, you know, people running third-party CI labs with their own hardware against Metal3, and at this point pushing all of the hardware vendors who are involved in ironic to do that same thing with Metal3 would be a hard ask. So I think we should steer away from trying to do things that would require us to do all that to have actually a tested solution. And I think the same approach applies to the networking. I would prefer that people put their effort into the Ansible networking project, and we consume that, and then we don't have to, you know, we're working one layer of abstraction up, basically. That would be the ideal for me. So I will look at the proposal at some point. I'm not sure if this may be covered in there already or not. I don't know, but yeah, that's maybe that's something we need to document somewhere, because it applies in general, not just to this.
So if I understood correctly, the network runner project will play the same role that Ironic is currently playing for BMO in terms of networking. Is this the basic idea?
It sounds possible to me. And that's a project we're already using in Ironic indirectly for switch management. So consolidating on that makes a lot of sense to me.
Sorry, folks. Thanks for the great conversation, but I think we have to move on with the other items since we have 15 minutes left, if that's okay.
Okay, we'll start the.
Yeah, and we can maybe continue the discussion over the meetings that we have every Friday and on the proposal, if possible. Is that okay, Shukun?
Yes, yes.
Thank you. I hope you're seeing my screen. I shared it back. Okay, then next, thanks, Shukun. Let's move on. The next item from Arda, requesting reviews for PRs, enabling validation webhook for BMO. Arda, please go ahead.
Hello. I am trying to enable the validation webhook for bare metal operator, and the main PR is working on Minikube cluster without any problem as a standalone. But integration tests are failing, and these two PRs to fix that. And I run on my local these three PRs combination, and it worked without any problem. And this could be great if you could review these, especially the last two PRs. to move on. Thanks.
Thanks. Yeah, I think there were some comments on Metal3 Devenv. At least I was a bit like retriggering it. I'm not sure if the tests are passed. Okay, so they're running now. I will try to spend some time on this, reviewing it.
Thank you. Because I especially ask in our community meeting because I don't want to miss anything. It is working on my local, but maybe I miss something. And because I have one chance to merge them all and run again. Otherwise, I open some PRs because there are different 3 PRs and it should work. Combination of all of them. It is difficult.
Yeah, I can imagine. So, but they can pass the integration test independently of each other.
Yeah,
right?
yeah.
Okay. I see that BMO has got like a lot of reviews already. So we need more reviews on the CapM3 and Metal3 Devenv. And yeah,
Yes.
Sure. I'll try to look into this and like tag some folks to look into this.
Thank you.
Thank you. Are there any questions regarding this patch? Okay, then thank you. Let's move on. Next item from Ashu or Sumit, issue with Prow cluster. Ashu, please.
Yeah, so yeah, this is Subhit here. So for this PR, like this PR, I'm updating information on behalf of Ashu. So this PR is running downstream well, but seems like there are some issues with the process. So can someone take a look, and because we don't have an permission or access to like fixing the thing. So.
Yeah, I think we are seeing something similar in one of the CapM3 PRs that we had with unit tests. Custom resource definition. Have you tried to? Yeah.
In the local system, this is working well. That is what is updated by Ashu to me. So, or if there are any comments, you can share so that we can take a look.
Sure. Yeah, I can also take a look onto this. I think we saw that in CapM3 in one of the PRs. Have you tried maybe push once again and like retrigger it, since like this was failing 11 days ago? And I'm not sure if that helped, but I can take a look after the meeting if that's okay.
Okay.
Or is someone in the call have like straight answer to the failure maybe? Okay, then let's take this like after the meeting. We can sync offline.
Thank you.
Thanks. Okay, next item from Dimitri, fixed config drive handling. Dimitri, please go ahead.
Thank you. It's not about the whole patch, but about one of its aspects. So while working on something else, I noticed that our config drive handling has a few flaws. This patch fixes them, but we had a discussion with Steve, and we decided to bring one of the aspects for a wider discussion, because right now, a config drive is only built if user data is populated, which is clearly wrong. You can have a config drive with only network data, only metadata. The contentious aspect is my initial version of the patch only created config drive if there is any user provided input. So user data, metadata, or network data. Steve is suggesting that we always build that because we always have some default metadata. We had it before my patch. So the question is, does anyone have any objections if we start creating config drive always and always provide at least the default metadata?
It's not clear to me why we were ever making it conditional on the user data, whether that was just a mistake or whether it's due to something in how Kapn3 uses it. So maybe one of those folks could clarify. Probably not right now because you'll have to go look it up.
Well, at least I can say that user data is not required from our perspective, from Ironic perspective, and from Cloud Init. And there is a valid case, for example, for providing only network data, or only metadata is a very common case because, for example, you only need SSH keys there, and then you use, I don't know, Ansible or whatever. And that can be done with metadata without user data or anything else.
Yeah, I tend to think what you're doing is okay, and what Steve's suggesting is probably okay too. But we just need folks who are more familiar with how Kapn3 uses it to chime in, I guess.
Yeah, I'm not sure also regarding the user data, like right away. But I'm not wrong, but I can check and like follow up offline maybe. But we are working on the CAP V1 Alpha 4 uplift, and there were some changes regarding the user data, if I'm not wrong. So that the user data might be not needed or something like that. I have to check, and then if I find something, I'll just ping you, Dimitri, regarding that in Kapn3.
Cool, thank you. I'll update the patch meanwhile and we can review it.
Sure, yeah, that's great. Are there any questions regarding this, objections, feedback? If not, then let's move on. Okay, this was the last item. We still have 5 minutes approximately. And is there any other topic that is not on the agenda yet and you still would like to take it up to the discussion? Okay, if not, thank you very much for the great discussion, for the demo. It was very nice. And have a nice rest of the day, and talk to you next week, Wednesday.
Thank you.
Thank you.
Thanks.
Bye.
Thank you.
Thank you.
Bye.
Bye.
Thanks, everyone.